Let's take a look at intermolecular forces, attractive forces between molecules. There's three types of intermolecular forces. The first one is called the London dispersion force. London dispersion force is a very weak intermolecular force caused by momentary change of electron density in a molecule. Electrons traveling surrounding nucleus along the orbitals can make one side molecule partially more negative with more electrons, and another side more positive with less electrons. This dipole in one molecule can induce formation of dipoles of its adjacent molecules. Okay, such induced dipoles can form weak dipole interactions. Okay, this kind of dipole interaction is called London dispersion force. Okay, let's take a look at some features about London dispersion forces. Okay, the first one, all the covalent compounds exhibit London dispersion forces. Okay, and the second one, London dispersion forces are the only intermolecular forces present in nonpolar compounds. Third one, the strength of London dispersion force is related to the size of a molecule. The larger the molecule is, the stronger the London dispersion force is. Okay, the second type of intermolecular force is called the dipole-dipole interactions. Molecular forces between permanent dipoles of two polar molecules. Okay, in contrast to the London dispersion forces, which are intermolecular forces between two momentary induced dipoles. The third one is called hydrogen bonding. Hydrogen bonding is considered the strongest intermolecular forces between molecules. Okay, most of the molecules are non-charged. Okay, except the proteins. Proteins are considered as a macromolecule, but the proteins carry charges. Therefore, in the molecule, an ionic bond can be formed between proteins. Okay, we know that ionic bond is stronger than hydrogen bond. Let's take a look at how the hydrogen bonding formed. Okay, hydrogen bonding occurs when hydrogen atom bond to oxygen, nitrogen, or fluorine in one molecule, electrostatically attached to oxygen atom, nitrogen atom, or fluorine atom in another molecule. And take a look at this example here. It's two water molecules. You can see two hydrogens covalent bonded to the oxygen in one water molecule, and they form hydrogen bonds to the oxygen in another water molecules. This dashed line represent hydrogen bonds, and the solid line here represents the covalent bond. Hydrogen bonds has a 10% shared electron pair. Therefore, it's considered to be a partial covalent bond. That's the difference between hydrogen bonding and dipole-dipole interactions. Okay, we have three liquid physical properties. Liquid physical properties related to intermolecular forces. The first one is called vapor pressure. In a closed system, wave pressure is the pressure exerted on container walls by gas molecules in evaporation, condensation equilibrium with the liquid phase. The vapor pressure exerted by a particular liquid depends on the identity of liquid and the temperature. Okay, vapor pressure increases with the increasing temperature. Okay, the second liquid property is called viscosity. Viscosity is a measure of liquid resistance to flow freely. Compounds with strong intermolecular forces tend to be more viscous than compounds with weaker forces. The larger the molecule are, the more viscous the liquid. The last property of liquid is a surface tension. Surface tension is a measure of resistance of a liquid to spread out. The stronger the intermolecular force, the higher surface tension. All right.